Hello and welcome everyone. Our today's question is very interesting. It is based on dynamic programming. So I will solve this question starting with recursion. Then I will optimize this code using dynamic programming and do this in memoization. Then after that I will convert this into tabulation, and as it is expected we have to do in of n space. After doing so, I will optimize this code, so space optimization, and I will do this in O of one space. So timestamp is given in the description. So let's understand what this question says. So we have a value n. I am taking n as 3. So I can start from any digit. So let's start for any random digit. I am starting for 4. From 4 we can stay on 4, so we have to make n digits, so I can stay on 4 and stay on 4. So this is one possible solution, and on 4 I can move up, down, left, right. So if I hold on 4, then I will move up. So this is one another uh, solution. And 1441, then 447, then 445, and that's all. So if I stay on 4, then I can move to 1. Then after that I will stay on 1. Then on 1 I will move to 2. Then from 1 I can move 1 4 also. So this is one another. So I hope you getting it. So star and hashtag is prohibited. So from 0 I can only move to 8, and from 8 I have 5 options. From 8 I can stay on 8, and up, down, left, right. So 4 other options. So let's build the approach now. So I have to build three three numbers. So 3 numbers I can start from any number. So run a loop. So I can run from 0 till 9. So we have a number starting. So I am starting from this ith number, and I have to build n numbers. I have to build n numbers starting from I. So let's build our solve function. So in the solve function we have int I and int j. Now let's understand what the base case will be. If this is our j, so n, this is our n. If our j is 1, I have to take only one number. So if j is equal to 1, so we will just return 1, means we have found digit. So this is our base case, and this will return long, and here also I have to return long answer. First I will take answer as 0. So starting from 1 till 9 I can build many possible solutions. So I have to add on answer starting from every I. So after that I have to return answer. So let's build the solve function approach. On solve function I am returning 1, and like let's take an example. I am I'm starting from 5. I'm starting from 5, and I have to build 3 numbers. So from 5 I have many options. From 5 I can stay on 5, and I have to build 2 numbers now. And from 5 I can move to 2. I have to build 2 numbers now. From 5 I can move to 4, and 2 numbers now. And 6, 2 numbers also. So 8 and 2 numbers also. So as you can see we have many options. on each and every number we have different type of option. So for that I have to take one data structure. So I have taken list. So it will tell me I have to the list from 0 till 9. So this will tell me how what are the possible values after 0. So after 0 I can only move to 8, and on 1 I can stay on 1. So on 0 I have also one possibility as 0. So on 1 I can stay on 1 and move to 2 and move to 4. So this is my list. So this is my list. I have a brute force that. So let's call it neighbor. So run a for loop neighbor, nbr get neighbors from list, list dot get of I, assume 5. So what are possible values after 5? So after 5 we have 5, 2, 4, 6 and 8. So it will travel to 5, then 2, then 4, then 6, then 8. Then I have to call solve function to neighbor, and I have considered one value, so j will decrement by 1. So j will decrement by 1. Then after that I have to return its summation. So let's consider summation as temp. Temp is equal to 0. So let's add this value into temp. Temp plus is equal to, then after that return your temp. So this is approach, this is the approach. So let's get back into the code. So first fill. So fill value, we have a list. So we have 0 to 9 indexes. So I have brute force the code. So this is ugly, I know, but I will optimize this code. So let's stay on that only. So then I am running memoization function. So memoization I have an answer and 0 till 9, as I have discussed 0 till 9. Then temp, then I have to build solve. So if j is equal to 1, then return 1, then temp, then neighbor, call the neighbor, then run your for loop with neighbor and j minus 1. After that return temp, and here add your temp value into the answer and return your answer. So as you can see we have two parameters I and j, I and j. So I and j, I can be from 0 to 10. So 0 to 9 indexes. So I have to consider. So I here 0 to 9. I have to take 10 indexes. What about j? J I have to build till n. So n I have to build till n, 0 till n, 0 till n. So I have to make n plus 1 array. On the solve function, there can be many sub problems that are overlapping. So to avoid that, we have to use dynamic programming. So let's build an array now, 10 and n plus 1. Just pass your dp, get your dp, and pass your dp. So save your state, I and j state, I and j state. I have saved the state. Now just check. If it is not null, then return dpij. So I have converted this code into dynamic programming. So we have done with our recursion and memoization code. So now it's time for tabulation code. This code will run fine, and it's the tabulation code. First check. I have to just build the logic around solve. So this is my solve function. I have to build the logic behind this. So overall code is same. So tabulation fill and answer. dp, then 0 till 9. So what is this? So if I have to convert this code into tabulation, on tabulation first check what is the base case j value. So this is my dp, and what does base case says? It says if j is equal to 1, then field 1. So I can be anything. This is my I and this is my j. So it is saying if j is equal to 1, just fill your value with 1. So I can be anything from 0 till 9. So I, then j is equal to 1, I have to fill 1. After that, we have this for loop, 0 till 9. Then inside we have recursion code, solve function. So first build the logic behind this. What is this? It is saying I have to fill 0 till 9. So this is 0 till 9. Then on every I have to fill the value for n. So it is starting from 0 till 9, and I have build the logic behind 1, then starting from 2. So if j is equal to 2, understand what this memoization code does. So in this code I have a loop from 0 till 9, and it is filling the value. So for every I, first it will fill 0 index value, then it will fill 1 index value, then it will fill 3 index value up to 9, and I am accessing the last element. So what does that mean? So I am accessing the last element I and n. I am accessing last element I and I am getting temp. Then after getting the temp, I am adding my temp value into the answer. So what does that mean? So 0 till n, which means if I start from 0 and I have to build n numbers, and if I start from 1, I have to build n numbers. If I start from 2, I have to build n numbers. What are the possible ways to build n numbers? If I start from 0, if I start from 1, if I start from 2, what are the different ways I can build this number starting from different i's, and I have to build n numbers. So this is about the memoization code. Now the main part is how we can convert this memoization code into the tabulation code. First, let's take a test case. I have to start from 5 and I have to build 5 strings, 5 characters. So I can, from 5 I can go to 5, then I have to build 4 characters. From 5 I can move to 2, 4, 6 and 8. So 2 with 4, 2, 4 with 4 characters, 6, then 8. So I can move in these directions. As you can see, 4 is same. 4 is same. So what is 4? So this is the starting index, and second parameter is n. N means we have to build n characters, and here n means we have to build n characters. So n value 5 is dependent on the smaller value, which means first I have to fill the smaller value, smaller and value. So I have to first fill 2, then 3, then 4, then I have to fill n. So I have to start a loop from 2. Why not 1? Because we have already filled 1 and we filled the value with 1. So let's run a loop from 2. So this is our j. I have to start from 2. Then on 2 we have this type of directions. So from 2 I have to fill all values. I have to fill all values for current n. So for all values I have to run a loop, I loop. So this is same as this loop that I have written here. So inside this we have a solve function, and on the solve function I have written the base case. Here I have written the base case. After the base case we have this. So neighbor, so just write your neighbor. So temp, so same as this, then neighbor, then temp, neighbor and j minus 1, as I have written here, neighbor and j minus 1. Then fill your temp value in ij. Then fill your temp value in ij. After doing, we have to find how many different sequences we can make, starting from ith value, and we have to make n characters. So we have filled our dp array. So we then run a loop from I. So inside I we have to check. Let's starting from 0 and I have to make n characters. Starting from 1 I have to make n characters. Starting from 2 I have to make n characters. So this is same as this value. So 0, so 0n, then 1n, 2n, 3n, 4n, 5n. So this is same as this. So as I have written here. So temp I and n, which means I can be 0, can be 1, can be 2, so till 9. So 0 and n. So 0n, 1n, 2n, 3n, 4n. So I have to take the summation of the last values. So this is all about the tabulation code. Just one step remains, return our answer. So we have returned our answer. This code will run fine. So it's time for remove the ugliness and make this code a little bit beautiful. So instead of this, so on the all possible values 0 0, so from 0 we can move to 0, so from 0 we can move to 8, so from 2 we can move stays on 2, 1, 3 and 5. So just comment out this code and remove your fill function. And on the neighbor part I have to rewrite our neighbors. So I make my dial array. So 1 2 3 4 5 6 our dial. Then I have to make another array directions. So on the I and j direction I can stay on I and j. So I have to addition 0 0. Then I have one possible solution, go up, so I minus 1, go down I plus 1, go on the left direction I and j minus 1, go on the right direction I and j plus 1. So we have these 5 directions. So as I will return 0 0, then 0 I minus 1. So I minus 1 means so 0 and I minus 1 here, 0 and 1 here, then 1 0, which means down, minus 1 0 goes up. So we have these 5 directions. Then I have to make an array find id. So I will talk about this in later. So if I'm starting from I value, if I'm starting from I value, I have to just check which is the index of the ith value. So suppose I is 6. So 6, I have made a dial. So here dial, on the dial I have to just check what is the index of 6. It is 0 1 1 2 1 2. So this will find id will give me id. So so as you can see, my rows is 4 and my columns is 3. So I have to traverse in these values and just check which value is equal to your number, then return its index. So id will give me index, then just traverse in all the directions. So suppose 4, on 4 we can move to up down left right, so stays. Then just build your ni and nj, next I and next j. After doing so, just check whether it is a valid index or not, because there can be a chance that we go out of the index, or we will move to star and hashtag. So for that I have taken -1 and -1. So let's build our valid function. So this will give me boolean if I goes outside the matrix or dial is -1 on stars and hashtag, so it will give me false, otherwise true. So if I get a valid index, then this is my neighbor. So neighbor int nbr, as here nbr, so it is dial ni and nj. So ni and nj, as you can see, it is a valid index, and this is my neighbor. Then just traverse into your neighbor, temp dp neighbor and j-1. So I commented out this code and just make my dial and direction. So this is more beautiful and more understandable. So this is about the tabulation code. It's time for space optimization. So what does this function do? If you carefully observe how we can space optimize this, I have to traverse from 2 till n. We have to traverse from 2 till n, and inside that, if you observe, we have i's, different i's, that's not an issue. And then inside that we have this function and this direction. Then on the direction I am accessing dp. So this is the main part. I am accessing dp of neighbor and j-1. If suppose j is on 5, if j is on 5, I have to check only dp j-1 and neighbor can be anything. Just have to check dp j-1. So j-1 means previous column. So I can optimize this code in column wise. So we can just make two arrays, current array of length 10 and previous array of length 10. Previous array of length 10. So it's time for optimization. Make two arrays, current and previous, of 10 sizes, because as you can see I range from 1 till 9. So after doing so, just fill your previous with 1. Why 1? Because instead of this value dp 1, so 1 means our column is 1. So here I am talking about this. So for 1 I can be anything, and our j is 1. So this is my previous and this is my current. On the previous every value is 1 now. So I filled 1. After that, just run a loop, j loop, then I loop, then temp, then find id. It is same as the previous code. Find id, direction ni nj, then just check whether it is a valid index. If it is a valid index, just get your neighbor. So this is my neighbor, and then we have previous. Why previous? Because here I have written dp of neighbor and j-1 index. J-1 index means previous column. So this is my previous column and this is my current column. So j-1, I am only interested in j-1 column. So previous and current. So as you can see, current. So dp of j means current. Then just reinitialize your previous and your current. This is my previous, this is my current. After filling my, this will become previous array, and I have to fill new current array. So just reinitialize your arrays. So previous and current. So current. After doing so, we have this for loop 0 till 9, and I have to consider n column. So dp I means row and n means column. So I have to consider last column. On the last column, I have made current to new array, and previous contains all the values. So this is my previous, and I have made current as new. So I have to traverse inside previous. So just take your values from the previous and return your answer. So this is the most optimal code. So let's talk about the time and space complexity. So if I talk about the time complexity, it is order of n. Then inside this we have another for loop. Its time complexity is order of 9, which is constant. And inside that we have another for loop. So directions, the maximum direction can be 5 directions. So inside that we have no another for loop. So its overall time complexity is order of n. What about the space complexity? So its space complexity of 1, which is constant. So I hope everyone understood. If you guys face any doubt, feel free to ask in the comment section. Thank you all for watching this video.